Um, After chatting to some of you this morning on the Teams meeting, okay, it was great to see you. I know a fair few didn't get in, so it is something we might do again in a few weeks' time. But there's been some issue, of course, with uh, these energy transfer questions, okay, and so I'm quite keen to go over them with you, just to kind of iron out a few misunderstandings, possibly. Okay, so let's just run through it. Question one, less than 1% of light energy hitting the sea is used by the algae. Okay, suggest what happens to the other 99. Well, if you go straight to your notes, you will find that there's some reference to things like reflection. Okay, that a lot of light doesn't actually get absorbed or reflected. Here's a mark scheme, misses the algae altogether. Okay, the sea's not full of algae, it's got some. Other plants absorb it, or some of it's changed into heat within the water. Okay, so those are the kind of marks that you need to put down there in order to get one mark for that one. Okay, so that's straightforward enough, I think, and that's just learning from your notes. The mathematical ones, though, I think are posing a little bit of difficulty. Okay, B, how much energy trapped by the algae passes to decomposers? So what you're asked is how much is here, okay, from this 20,000 that is absorbed. So you need to work out what's lost in other ways. So respiration up here loses 17,000, but also 1,600 is passed on to fish. So the short sum really is, it's your 20,000, sorry, 200,000. Take away your 17,000 for respiration, take away your 1,600. And if you do that, you get an answer of 181,400, and of course a unit. So 181,400 kilojoules. Okay, and there's 3 marks, and that's just simple subtraction. Okay, calculate the percentage, okay, of energy trapped by the algae that passes to the secondary consumer. So what you're being tested here is how much gets to the secondary. Well, if you go back to your understanding of this, you've got the producer, this is then the primary consumer, and this here is the secondary consumer. So we're interested in humans. How much do the humans get of the original 200,000? So those are the numbers you need to use. 200 divided by 200,000 times 100. Now when you calculate that, there's obviously a bit of cancelling out you can do, but you should find it's an answer of 0.1%. Okay, it will be very small, right? If you're getting an answer quite large, then you've done something wrong there. So 0.1%. And there you go, there's 2 marks. It then asks you, okay, this one was a bit of a challenge. Rather than eating fish, it would be better to use algae to provide food for growing human population. Use data from this food chain to explain why. Okay, when it says use data, it means you need to use your numbers. All right, so we will go back up here and let's just change my color. Let's go for green. What we need here is of the 200,000 kilojoules that algae take in, 1,600 goes to the fish. Okay, whereas by the time it gets to humans, there's only 200 left. So you really are asked to make some reference there to the fact that humans could, if they ate the algae directly, could probably gain that 1,600 kilojoules that the fish get. Okay, that we'll get at that level of energy rather way down at 200. So I suppose the short of it is, okay, that there will be more energy for each human by leaving out the fish. Okay, some of you talked about there would be less fish killed and so on. That wasn't really getting that. So I'll just put up the mark scheme there. You can pause this. You can see it's a shorter food chain. Idea of less links, therefore less energy loss. Okay, so shorter, less energy loss gets you a mark. And then the idea when it said use the data, you need to therefore quote some. And you could even have gone on to work out what proportion, 8 times more, 8 200s or 1,600. And then you could have said, well, excess 125 times more. Okay, if you'd done it compared to 1,600 divided by the 200,000 there. But certainly that point, and then some reference to that point there, I think, would have been what I think you could have come up with. Okay, now we'll go back to the question then here. Use a diagram to use calculate the percentage. Okay, so back to percent of energy reaching the primary consumer. that is available for the secondary. So what's going into the primary? Remember, this is producer, this is primary, this is secondary, okay, consumer, and that says 1y, 2y, that's the main base. So what it is of the 3,000 going into the cow, how much goes to the human? It's 123. So what is 123 divided by 3,000 times 100? Alright, and when you put that into your calculator, and I'll just do that now, 123 divided by 3,000 times 100, it's 4.2, sorry, 4.1. So 4.1%. Okay, again, answers in around no more than 10%. If you're getting higher than that, then it should have alarm bells. Explain 2 reasons why this decreases decrease in energy available to the secondary consumers. Well, again, back to notes. Put up the mark scheme for this section. Okay, there you have it. Energy lost as heat or respiration, movement, excretion, and then parts of the plant cannot be digested. Okay, so there's a lot of fiber in there. So there's your mark scheme. You can pause this and obviously look at it and make sense of it. Okay, but that's a little overview of energy transfer, and when we get back to school, we'll be able to go back over it, but hopefully that make a little bit of sense. Bye.